Hey everybody, welcome to another session in this AI trail. As you see on the screen, we would be diving into the arena of neural networks in this video, right? So a lot of people have curiosity about, what exactly is a neural network meant to solve, and why do we not use like traditional machine learning, right? When we have these algorithms, why do we need neural networks? So let's deep dive into that discussion, and then let's get introduced to neural networks in the subsequent discussion. So let's take the whiteboard. So in machine learning, right, we have many algorithms like the ones meant for, like, say, regression, where say we're predicting something for a continuous variable, like say house price prediction, right, as a function of various parameters, like say the carpet area, or maybe the number of rooms, and then number of floors, so on and so forth, right? You predict the house price continuous. You use linear regression for it. And then you have classification algorithms where you want to classify something in one or many classes. So like for binary classification, you use logistic regression. Then you use something called as k-nearest neighbors for like a multi-class classification. You also have something called as support vector machines. Then you have decision trees. Then you have random forests, right? Where now the common thing here is that you have certain features, right, in each of these. Like say for logistic regression, you have features that talk about a person's medical condition. Let's say his heart rate, his BP, and then his other diagnostic. And then out of these features, you combine them, and then you basically find some conclusive uh, probabilistic determination from those features to uh, basically decipher whether it's going to be, say, a cancer or no cancer. Similarly, k-nearest neighbors, you have certain features like, say, the diameter and radius of diameter, and then the weight of a fruit, and then you classify that fruit into categories, like whether it's an apple or it's an orange or things like that, just to make it simple, right? So in all of them, you have certain features, and then you determine the output classification based on those features. Now let's take another problem where, let's say, you have to classify a handwritten digit, right, into its respective number. Let's say, as human beings, we can easily do that, right? Let's say this is the number 7, but we know that this is also the number 7. 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 So as human beings, we can easily detect that all of these are number 7s, right? But then which of these machine learning algorithms are you going to use to solve such a problem? And then how are you going to create features from this? Like, are you going to just feed this image and then mention to the computer that this belongs to the digit 7? And then if you see many such images, then uh, try to conclude that it belongs to the number 7, right? Are you going to do that? Yes, you may do that. But then how do you come up with the features in this case? So it's hard to solve this problem using classical algorithms, right? So here is where your deep learning comes to the rescue. Right, let's say another problem where you have, say, a speech in one text, like say in English, and you translate that to Spanish. So which classical algorithm are you going to use here? This is where your natural language processing based on, say, deep learning comes into the picture, right? And they have advanced to such an extent today that you have the transform architecture, and then your large language models based on the transform architecture. We'll take that discussion in further videos, right? Let's look at the basics today. So let's focus on this problem at the moment. Like say, how do you solve this using deep learning? So that's where deep learning that uses neural networks comes to your rescue. So what are these neural networks now? These neural networks are nothing but they are just like representations of the human brain, right? They used to mimic the human brain, right? The human nervous system, neural system. So it essentially looks the same way, like just like you have neural connections in your brain between the input and the output. So the input basically looks like this. You have input nodes. Each of these nodes carries some values. Then you have a hidden layer, and then you have something called as an output layer, right? So now what happens is that each of these nodes from the input is connected to every other node in the hidden layer. We are talking of a fully connected network, okay? There are different variants of networks, but let's look at the simple one today. The simple one is a fully connected network where each of the input nodes is connected to every other node in the hidden layer, right? Right, and then from this hidden layer interprets the inputs accordingly, and then provides the output like this. So this in turn again has each of these connected to every other node in the output layer. All right. And here in the output, you determine whether it's the number 7 or not 7. All right. So this is how it's basically structured to operate. Now, how does it exactly operate here? What's exactly happening here inside? So let's look at this number 7. Let's say we have the image of a number 7 like this, right? Right. Let's say the number 7 is in black in color. And this is the total image of the number 7. Now, if you look at any image, right, let's say this is a 28 by 28 pixel image. So every image is divided into a smallest portion called as a pixel, right? Let's say this is not a very sharp image, but let's say it's a 28 by 28 pixels. So this is 28 pixels and this is 28 pixels. So this image is basically going to look something like this, right? Let's say it's 28 in number, it's not to scale, but then let's say this is 1, say 1, 2, 3, 4, 5, 6. Let's say this is 28 total. So you have 28 cells over here and then 28 cells over here. So this image is composed of two kinds of cells, right? White cells and the black cells. So these are the white cells, right? And then these are the black cells, right? Right? So let's denote the white cells by a 0, the black cells by a 1. Okay. So what's essentially happening here is you see these are the input nodes. These are going to be like not just 1, 2, 3, 4, 5. I mean, this image, this is only for representational purposes, but then in reality, this is going to be each of these 28 by 28 pixels. So in all, we are going to have 28 into 28 equals 784 total inputs, right? So some of these inputs are going to be white and some of them are going to be black. Essentially, some of them are going to be 0 and some of them are going to be 1, right? So what's happening is each of these nodes is getting multiplied by something called as a weight, right? So let's say something like W1 into 0 plus W2 into 1 plus W3 into 1 plus W4 into 0, something like that is happening, plus dot 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 plus dot 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 W784 into 1 or maybe 0, whatever that is, whether it's a 1 or 0, right? This is what is happening over here. And then this weighted product, right? This is a weighted product going into one node, right? From each of them. And similarly, there are certain other weighted products going to another node. Like say this was W1, right? Then you can have say something like W1, W11, W12, W13, W14 for the other node like this. Similarly, W21, 22, 23, 24, 31, 32, 33, 34, right? Or maybe let's say this is W11, 12, 13, 14. This is W21, 22, 23, 24. W11, W12, W13, W14, W21, this one. This is W21, W22, W23, W24. Like this. You got it, right? It's like a matrix. right? So each of these weighted products is going to each of the hidden nodes here. And then based on this is basically coming up with a weighted product, with a certain weighted product, which is again, so again, these four nodes are coming up with their own weighted product and then going back to the output nodes here. And based on the final weighted products, it's basically concluding that, okay, if the weighted product has a certain kind of a value, then it's basically a number 7. If it has a certain other kind of a value, then it's basically not 7. Okay, so based on the number of inputs that you train, there's only one input, but there are some other inputs that are going to be maybe looking like this, right? They are going to have their own weighted products like this. Each of them are again going to go inside, and then they're going to have their own value. So it's going to find some patterns in these images based on the weighted products, right? And based on that, it's going to basically coming up with its conclusions that if the weighted products fall basically into these ranges, then it's going to be a number 7, otherwise not 7. So that's how it learns patterns in these images and tries to conclude what category of numbers this image basically belongs to, right? So this concept can also be used in object detection and object identification, right? We have certain variants of neural networks for that, like convolutional neural networks, and we will come to that later. But like this is just to illustrate the concept of a neural network, right? I hope this is clear. Yeah. So I hope this was useful. If you have any questions or if you have any confusion about anything, just let me know in the comment box below, right? About why you require a neural network, or maybe if you did not get this weighted product or something like that. Just let me know and I'll be happy to explain that further, right, in another video, right? There are many details to a neural network. We'll take them in subsequent videos, but then this one was meant to introduce you to one. So I hope this is useful, and I hope now you got the clarity on why you require a neural network and basically deep learning to solve certain problems which are not traditionally susceptible to be tackled by using conventional classical machine learning methods, right? So I hope this is useful. Until then, please take care, continue to study, continue to enjoy your studies, and see you in another video. Until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.